In January 2024, a company that makes chips, tiny pieces of silicon no bigger than a postage stamp, briefly became the most valuable company on Earth, worth more than $3 trillion. Not a bank, not an oil company, not even Apple. A graphics chip company that Jensen Huang started in a Denny's booth with two friends and $30,000 in 1993. The stock had climbed 24,000% from its lows. The man at the top was wearing a leather jacket, which he always wears because at a certain point you stop dressing for the meeting and start dressing for the legend. But here is what makes this story genuinely strange. The thing that made NVIDIA a $3 trillion empire was not what they designed the chips to do. It was what their customers figured out they could do with it. This is the story of how a company that thought it was making video games prettier accidentally built the engine that now powers all of artificial intelligence, and how one obscure, unfashionable bet made almost 20 years ago turned out to be the most valuable decision in the history of technology. 1993, San Jose, California. Jensen Huang was 29 years old. He had grown up in rural Taiwan, spent part of his childhood at a boarding school in Kentucky, where he mopped floors and cleaned bathrooms alongside teenagers who had done genuinely terrible things, then worked his way through Oregon State and Stanford before landing engineering jobs at AMD and LSI Logic. He was not yet famous. He was not yet rich. He was a guy with an idea, a co-founder named Chris Malachowski, another named Curtis Priam, and a regular booth at the local Denny's where the three of them would sketch out what a new kind of graphics chip could look like. The pitch was simple. Personal computers were finally fast enough that real-time 3D graphics were possible. The problem was that the chip handling graphics inside most machines was primitive, a generalist processor. Being asked to do specialist work, like asking an accountant to also lay bricks. NVIDIA would build a chip dedicated to nothing except graphics. A single-minded, obsessive piece of silicon that knew how to do one thing and did it extraordinarily well. What nobody fully appreciated, including Jensen Huang, was the hidden engine underneath that design. A graphics chip renders a 3D image by computing the color and lighting of millions of pixels simultaneously. There is no sequential shortcut. You either calculate all the pixels at the same time, or you wait forever. So NVIDIA built a chip with thousands of tiny processors that fired in parallel, working in concert, doing enormous amounts of math all at once. That parallelism was the key. It just took another 15 years to realize you could point it at something other than video games. By the late 1990s, NVIDIA had won the graphics chip wars outright. The enemy was a company called 3DFX Interactive, which had dominated PC gaming graphics for years and had the kind of brand loyalty among gamers that would make a sneaker company jealous. NVIDIA out-engineered them, out-shipped them, and finally bought their corpse in 2000. The GeForce cards became the gold standard. Jensen Huang started wearing the leather jacket to every public appearance. The company was worth a few $1 billion, growing fast and completely confident it understood its own business. Then in 2006, NVIDIA made a bet that almost nobody in the industry cared about at the time. They released a software platform called CUDA, Compute Unified Device Architecture, which let programmers write general-purpose code to run on NVIDIA's GPU hardware. This was not for games. This was for scientists, researchers, and engineers who needed to crunch enormous quantities of data as fast as possible. The pitch was, our chip is extraordinary at doing millions of calculations simultaneously. What else in the world needs that? The market shrugged. CUDA generated almost no revenue for years. Most analysts ignored it entirely. September 2012, University of Toronto, two PhD students named Alex Krzyzewski and Ilya Sutskever, working under legendary AI researcher Geoffrey Hinton, entered a computer vision competition called ImageNet. The task, train a machine to look at photographs and correctly identify what is in them. A dog, a chair, a fire hydrant. 120,000 labeled images. 16 million parameters to calibrate. Every other team in the competition used traditional handcrafted algorithms. Krzyzewski and Sutskever used something different, a neural network, a kind of artificial brain modeled loosely on how human neurons connect, trained on two NVIDIA GTX 580 gaming cards because GPUs were the only hardware on Earth fast enough to handle the computation in a reasonable time frame. AlexNet won. It did not just win. It annihilated the competition by a margin so large the entire field went quiet. The second place team had a 26% error rate. AlexNet's was 15%. That gap was not a better algorithm. That gap was a new era of computing, arriving without warning at an academic conference in Florence, Italy. Within months, every serious AI researcher on Earth was ordering NVIDIA GPUs, not the professional server models, the gaming cards, the ones teenagers used for Minecraft, because those were the ones you could actually buy quickly and plug into a workstation. NVIDIA found itself at the center of a gold rush they had not advertised for. Jensen Huang understood immediately what was happening and moved the entire company toward AI AI infrastructure faster than most of his board felt comfortable with. He launched the Tesla GPU line for data centers. He launched the DGX1 in 2016, a server the size of a mini fridge that cost $130,000 and delivered AI computing power that would have required a warehouse-sized supercomputer a decade earlier. He personally drove a DGX1 to OpenAI's office in San Francisco and handed it to the team as a gift. "This is the first DGX1, he said. "It is for you." OpenAI would eventually use NVIDIA hardware to train ChatGPT, but that story comes a little later. Meanwhile, a second and entirely unexpected wave of demand arrived from the cryptocurrency mining industry. It turned out that mining Bitcoin and Ethereum required exactly the same kind of massive parallel computation that GPUs were built for, these billions of simple math operations running simultaneously. By 2017, mining farms across China, Iceland, and Eastern Europe were buying NVIDIA graphics cards by the tens of thousands. The demand was so intense that gaming stores ran out of stock within hours of receiving shipments. Cards that retailed for $400 were selling on the secondary market for $1,200. Gamers who just wanted to play games were furious. NVIDIA executives were privately delighted. The stock went from $20 in early 2016 to $270 in October 2018, a 13-fold increase in under 3 years. Revenue was doubling. Analysts were using words like generational and dominant. Jensen Huang was being compared to Steve Jobs, to Elon Musk, to the founding fathers of Silicon Valley. His leather jacket had become an icon in its own right. NVIDIA's CEO started wearing it to conferences like he was the Mick Jagger of semiconductors, which, by late 2018, was not entirely an unreasonable comparison. But beneath the spectacle, a structural flaw had been quietly built into the foundation. NVIDIA's data center business was real. The AI tailwind was real. The gaming business was real. The crypto boom, however, was not a business. It was a bet, and bets eventually are called. Late 2018, the crypto market collapsed, and prices dropped 60% in under 3 months. Mining became unprofitable almost overnight. The farms shut down, and suddenly an ocean of lightly used NVIDIA cards flooded the secondhand market at prices far below retail. Gamers who wanted a new GPU could buy a practically new mining card for half the cost of a new one. New GPU sales went off a cliff. NVIDIA's next earnings report missed analyst expectations by hundreds of millions of dollars. The stock fell from $270 to $124 in less than 3 months. That is a 54% decline. Institutional investors who had loaded up at the top were not philosophical about it. In a warehouse outside of Chengdu, a man named Wei had invested his family's savings into 40 NVIDIA mining rigs 18 months earlier. He had run the numbers carefully at 2017 prices. At 2018 prices, the numbers no longer added up. He sold the rigs for a fraction of what he paid, covered what he could, and absorbed the rest. He was not a hedge fund. He was a man who had believed the projections. NVIDIA's chief financial officer acknowledged the company had miscalculated cryptocurrency demand. Jensen Huang used the word humbling. Then in 2020, NVIDIA announced a $40 billion acquisition of ARM Holdings, the British company whose chip designs are licensed inside virtually every smartphone on Earth. It was going to be the deal that made NVIDIA untouchable, data center dominance plus the entire mobile computing ecosystem. Regulators in the United States, the United Kingdom, and the European Union spent 2 years reviewing it, decided it would give one company far too much control over the global chip supply chain, and blocked it from every direction simultaneously. The deal collapsed in February 2022. $40 billion in deal fees, 2 years of management attention, and a complete dead end. Then, 9 months later, on a quiet Wednesday evening in November 2022, OpenAI released a product called ChatGPT to the general public, and the world discovered it had a very large GPU problem. The world discovered in real time that thinking at scale requires hardware. Every time a user types a sentence into an AI chatbot and it generates a response, hundreds of billions of mathematical operations fire simultaneously inside a data center. Running an AI model is not like running a spreadsheet. It is closer to rendering a 3D image of every possible sentence that could follow your sentence simultaneously, millions of times, until the most statistically correct one emerges. It requires, in other words, exactly what NVIDIA GPUs were built to do. Within weeks of ChatGPT going viral, the waitlist for NVIDIA's H100 AI chip, their most powerful, stretched to 18 months. Microsoft was ordering them in massive quantities to run ChatGPT at scale. Google was ordering them to not fall behind. Meta, Amazon, 100 well-funded AI startups. All of them needed the same chip. All of them were offering NVIDIA whatever it wanted. NVIDIA's annual revenue went from $27 billion in 2022 to over $130 billion in 2024. The stock, which had been languishing after the ARM collapse, went from $150 in January 2023 to over $800 by mid-2024. By June of that year, NVIDIA's market capitalization briefly exceeded $3 trillion. It was the most valuable company that had ever existed. Jensen Huang showed up to give a keynote address dressed in the leather jacket. He had not changed the jacket. He had just waited long enough for the world to catch up to what the jacket already believed. Here is the thing about NVIDIA that the $3 trillion number almost obscures. The reason they won the AI race is not primarily the hardware. Dozens of companies can design fast chips. AMD makes good ones. Google makes custom AI chips. Amazon and Apple and Microsoft are all designing their own. The reason NVIDIA won is CUDA, the software platform released in 2006 that generated almost no revenue and that most analysts ignored entirely. CUDA is the reason every AI researcher on Earth learned to write code that runs on NVIDIA chips. It is the reason every major AI framework, TensorFlow, PyTorch, every model being trained anywhere on the planet, defaults to NVIDIA hardware. Switching away from NVIDIA is not just expensive, it is like asking someone to stop dreaming in their native language and switch to a language they studied for a semester in college. Jensen Huang made the CUDA bet in 2006 and held it for 17 years. While it generated almost nothing, the lesson is not that Jensen Huang is a genius, though he may be. The lesson is that the most valuable thing you can build is not a product. It is a dependency, a gravitational field so strong that everyone who enters it finds leaving more costly than staying. NVIDIA did not become the most valuable company in history by building better chips. They became the most valuable company in history by making sure that anyone who needed to think at scale had no sensible choice but to think on their hardware. The company that started in a Denny's booth in 1993 is now the company that the entire artificial intelligence industry runs on. Jensen Huang still wears the leather jacket. He just upgraded the Denny's.